Hello YouTube, De-bodgery here, aka Richard Gumfaw on Facebook. Welcome to the EV Components Review channel. This is a Flipsky 75-200 close-up teardown video. So yeah, we're looking at the shell on my camera, and the only thing I really wanted to show you here was those little witness marks. So you can see right here, you can see this one less pronounced, but that's where those two MOSFETs were rubbing on the anode. I've already run this controller. It did work, and it's not shorting yet, but that's going to be a problem. And let's pull up the board and show you where those capacitors are. Here we go. Flip this over. Okay, so this capacitor right here, that made the larger of the witness marks, and this edge of this capacitor made the other one. So these capacitors, they don't see very much voltage. They're like 12 volts or so. Actually, no, that one right there is on the high side, so that one might be seeing battery voltage, and that one's seeing 12 volts. But yeah, having your capacitors rub against something that is not supposed to conduct current, because it's aluminum oxide, but then it could conduct current, that's a bit of a problem. So yes, that's going to get changed because, well, that's going to create problems. Let me shift this over a skosh. There we go. So here, here, and here are your three MOSFET gate drivers, and they're this EG3112, which is a Chinese part. And let me pull that guy up real quick. Yeah, that's from a company called EG Micro, and they refer to it as a MOS IGBT driver. Yeah. But yeah, that's your gate drivers. Since we're looking at this, and all three of these gate drivers are effectively the same, and like this one here and this one here, you can kind of see it. So two resistors, a couple capacitors, a little diode, and the gate driver. Two resistors, a couple capacitors, and a gate driver. That's the whole thing. And this one over here is the same thing. Here's your two resistors, here's your diode, here's your gate driver. Don't know where the other capacitor is, but there's only one. Okay, somebody forgot one, or maybe they really made it small. That's weird. Anyway, yeah, they're all basically the same. That's one for each phase. These two little chips right here, I didn't bother looking them up. They are obvious what they do. They're a little DC to DC buck controller chip. It's got a MOSFET in there, a little oscillator, a couple other things like that. These little resistors and stuff around it, they tell it what voltage to put out. There's a little inductor, another identical same one right over here. So one's making 5 volts, the other one's making 3.3 volts. But it's nice that it's all DC to DCs rather than, like, say, just have this main one and then do a couple linear regulators. I'd prefer to have DC to DCs personally. This is your main DC to DC over here. And again, this is just a slightly higher current buck converter. This one actually sees pack voltage, so like, you know, 100 volt max. Whereas these ones don't. They're basically seeing like 12 volts because that's what this one's outputting. You have a diode in, have a couple capacitors for filtering, and that's pretty much that. Pretty basic stuff. These connectors are fairly good. They've got a little latching arm on them to keep them in place. And then the actual pins that go down inside here are more of like an edge blade sort of a thing that gets squashed between two spring-loaded contacts on either side. So it's a fairly reliable connector. They're cheap. Does that look a little dot or solder right there? Yep, sure is. Good job, Flipsky. Yeah, you saw me break that loose right here on camera. This chip right here, this is a precision dual op amp. And give me a second, I'll pull up that part number. I'm sure everybody's deeply fascinated by what that is. There it is. That's an LTC1051, another Chinese chip. You know, this is all basic, kind of low-grade Chinese production anyway. This guy here, this is a 4-channel software addressable SAR. And that part is ADS8634. I don't know what this chip does. I didn't read the spec sheet very far in, so I don't really understand what it does, but it's got 4 channels on it, whatever that means, and they're software selectable, and it's a SAR, software addressable whatever R is, is my guess. I don't know what it does. Anyway, yeah. Right here is your typical for just about everything that's VESC-based. STM32F405. Right here we have 4 LEDs for status and stuff. A little crystal oscillator, otherwise pretty mundane parts on here. That's I should before I flip it, I should point out one other thing. A lot of VESC stuff, like when I did the teardown for the 100-250 from Trampa, there was 4 little chips all in a row, and they were for phase filtering. And well, there is no phase filtering in here. And if you look on the website for anything from Flipsky, it will say in big red letters, be sure to turn off phase filtering. It's because, well, the electronics aren't here. They don't exist. You know, it's a way to cut corners. Backside of the board is pretty boring. Nothing here to see. You know, you can see circuit traces and the through holes for the pins. So, flip that out of the way, and let's look at the power stage. And first thing I'm going to show you is right here. There we go. So you can see this little board on top of the metal backboard down below. So the MOSFETs themselves, or I'm sorry, the capacitors, are soldered in this little circuit board, and then through this little bit of solder right here and the little via holes around it, that solders down to the main board. So that way they could use through-hole capacitors on a board that doesn't support them. Kind of clever-ish. Because, you know, like the capacitors that would go on here, you know, like surface mount ones, were probably more money, and so it was cheaper to do that. And yeah, you can see the MOSFET or the capacitor legs on the back, and they're soldered into that board on top, and then there's just simply holes through the metal backed board so that the legs go through. But yeah, they're just through-hole capacitors used on a single-sided, single-plane metal backed board. Kind of a clever use, I guess. So this guy right here, this is a diode. It's a Schottky diode, so it's a fast switching device, and it goes from battery plus to here. I don't know what exactly for. These two little parts right here, so it's a resistor and capacitor. The resistor, it connects up to the gate pin, which is right there, and this is the TOLL package. I definitely like this MOSFET package. But yeah, that's basically limiting gate current to the MOSFET gates. And these two MOSFETs are in parallel. That's the high side or battery side, battery plus side. And these two down here are the battery minus side or low side. And those guys are, well, you can see the part number on them. But yeah, hold on a second. Let me look up that part, which I had done already, wherever that was. There it is. So those are 15N10 MOSFETs from a company called Huayi, Huayi. I don't know my Asian components all that well, but supposedly these are relatively decent brands of Chinese MOSFETs. So, okay, sounds awesome. I know that me personally, I'm very much biased towards Western components. But, you know, this is an all-Chinese-made motor controller, and it was never expected to be awesome. So, you know, it works. It's good enough. Is it just going to blow up at the drop of a hat? No. But is it going to be awesome? Well, no, not that either. The shunts are kind of in an odd place. But, you know, when you've got a really small board like this, you kind of make compromises in some ways. So these are your two low-side MOSFETs. The shunts should be inside here. So right across here is where your phase bus is. And as you can see, there's no copper there. Yeah, those shunts should be on that phase bus, and then this battery, or this phase wire right here, should go to one side of the shunt, and the other side of the shunts should be on the phase bus. That way you can measure both when the high side MOSFETs and the low side MOSFETs turn on and off. But instead, because these are on the low side MOSFETs, you can only measure phase current when the low side MOSFETs are turned on. So, interesting-ish oddness with the current sensing shunts. Yeah, I don't know why they did that. Anyway, yeah, it works halfway, but this is Flipsky. They don't ever do really awesomeness stuff. Again, resistor, capacitor for gate driving and some filtering. Same thing over here, same thing there. Notice that there's no large ceramic capacitors anywhere here. Yep, they don't exist. And so, yeah, you just don't ever get high frequency noise on your power stage, right? Sure you don't. Yeah, they just didn't bother, you know, corner to cut. Up underneath here, and there we go. So 2 things I want to note here. So first of all, that is the one and only temperature sensor on the entire board. And it's over here on the corner. It's not like in amongst the MOSFETs. Like in here, that would be a good place to put it. In here would be a good place to put it. But nah, let's just stick it over there in the corner. Close enough. We're actually getting temps off the board, right? We're awesome. And we only have one of them. So yeah, again, this is typical, you know, kind of cheaper end VESC stuff, which is what Flipsky is. Just, you know, try to cut corners, make things cheaply, things like that. One thermistor will do that. I do like this though. So this right here is epoxy, and they epoxied in all of these pin headers on top of them being soldered in place. So they are holding in the top board by these pin headers. So I'll bet you that was to strengthen that. You know, like in testing or something, they found that those solder joints would break. And so they kind of reinforced that with some epoxy. So that's good. Good for you, Flipsky. Wish you did a little bit more, but, you know, they are cheap. The battery minus and battery plus bars, you know, they do have copper reinforcing on them. You know, the gaps between the bus and, like, the shunts and then the MOSFETs is not horrible. It's only a couple millimeters. It's not a tortured current path like, say, KO Moto does. You know, it's to the bus, to the shunt, to the MOSFET. You know, very short distances. So the fact that it's not reinforced, the fact that it's not really that high power of a controller anyway, and it's cheap, yeah, that's not really very surprising, and can't really complain about that too much. Battery minus, got a little gap between that and then the bus bar. I would like to see that bridge together, but, you know, again, it's inexpensive VESC, and you got another one up here for battery plus. So not really awesome, but, you know, it works. It's good enough, right? It's going to definitely run, and it is FOC, and it is VESC, and that's all good. So, yeah, it's not completely bad, but it's not awesomeness either. Well, anyway, I think that's it. Hope that helps some folks out. Satisfies your curiosity for another teardown. Next up, I will be doing eBMX. Yes, the X9000. We're going to get into that one, you know, with an overview, high side shot, and then get in and do a macro shot next. So look forward to that set of videos on the next set.